Hey guys, how you doing? Glad we're back. We are going to pick up here and move into dimensional analysis. Now, dimensional analysis is a big fancy term for doing math with units. It's also called the factor label method for converting units. Now, it's not just for converting units, right? This was taken from Wikipedia, this example that's given here, all right? But it's not just for conversion of units. Anything that we do in chemistry should be done with dimensional analysis. I'm going to tell you something, and I kid you not when I say this. I really didn't understand physics. I knew I needed to get to do it. I knew I needed to have some way to get through it so that I could pass, so that I could get my degree. And I knew that I was going to need some of the information. I was just having the hardest time understanding what was going on. And the only way that I was able to pass physics is because I understood the units. There are a lot of derived units that are used in physics. And so if I could get the units right, my answer to come out in the units that it was supposed to come out in, that meant that I set up my calculation correctly. And as long as my calculator didn't blow up, that number should be right. And it almost always was. So even though I didn't really know what I was doing, I could get the right answer. So this helped me to get through physics. Now, did I need to come back and take a look at that later? Well, yeah, actually I did. And fortunately for me, I had an opportunity to do that because I had to take relativity. That was part of what we had to do. So when you get to relativity, or at least my instructor, went through this huge lecture and he goes through all of the entire year of physics that I had already taken and barely understood. And he's doing this, and he went through 20 chalkboards the day that he did this, the big, big chalkboards. And he gets to the end, and I'm going, oh my God, I understood all that. And it's the end of class. And the bell rings, and he says, so if you got all that, it's all wrong. And I almost threw in the towel right there. I was convinced that I was not going to be able to do this. But, you know, we're talking about moving from the conventional ways of looking at physics into relativity, and so it's a shift in what we're looking at. So I understood why he said it, but it didn't make me feel any better. So I did get an opportunity to go back and actually understand what the heck I was talking about. But these units saved me. And so because of that, and because I know that they're so important, I include them everywhere. Right? Everything that I do has units on it. What we're doing is seeing how we can cancel units. Almost everything we do will involve conversion from one thing to another. Okay. Now those conversions use conversion factors. Those conversion factors are usually because something is equal to something else. Okay. So we talked about 1 inch equals 2.54 centimeters, right? They're equal to each other. That means that I can say that 1 inch divided by 2.54 centimeters is 1. It's the same thing as 1. So I can multiply by that, and I haven't changed anything. But that'll allow me to cancel my units. So that's a way for me to make sure that the math's set up right. Okay? If we wanted to set up and go from miles per hour to meters per second, I need to convert both the miles and the hours. Okay. I deal with the stuff on the top first. So if I'm in miles and I need to get to meters, I need to know how many meters are in a mile. So how many meters are in a mile? And that's this factor right here, 1609.344 meters in 1 mile. My miles cancel when I do that. And that leaves me in meters per hour, because I haven't canceled the hour yet. So meters per hour. So I'm not quite done, because I want my answer in seconds. So I need to convert from hours to seconds. I can do that in 2 steps. And I can say that there are 60 seconds or 60 minutes in an hour, and then 60 seconds in a minute, and do it that way. That's typically how I do things. Or I can say that 1 hour is 3,600 seconds, and do it that way. And then I cancel the hour there and the hour there, and that leaves me with an answer that's in meters per second. And so as long as I've set the math up right, which I did because I got the right units, and as long as my calculator doesn't blow up, that should give me the right number. Okay. And looking at all the things that I did, we have only this number should determine how many sig figs I have at the end. I didn't actually set this math up, so I stole this from Wikipedia, so I don't know if the sig figs are right. I'll just throw that caveat in there. So there you go. Okay. Okay. We can do this for stuff that's way more complicated than that, too. And one of the things I need to point out here is that we're talking about going from meters cubed of NOx to meters cubed of gas, right? And that's based on the information that we have here, so volumes and things like that. One of the things that we need to be able to talk about is how we get between all of those units. But as long as I have, meters cubed of gas cancels with meters cubed of gas. Minutes canceled with minutes. Kilograms times moles is in there somewhere. All right. Meters cubed of NO2 cancels with meters cubed of NO2, which is why we're introducing this kilograms times meters here, times moles here. We then need to get out of the kilograms times mole to get into kilograms. So we multiply by the number of kilograms per kilogram mole. Okay. And then we want it in grams, not in kilograms, so we multiply by 1,000 to cancel out that kilogram. And that gives me 2 grams per hour. Okay. So again, I often don't know how to get from where I am to where I need to go. What I need to do is in each step, I need to take care of one unit until I get to the units that I need, and then I can do what I need to do. And I know it's been set up right because I've canceled all those units, except for the ones that I was looking for. Okay? That's how I handle this. You are going to watch me set these up like this. Now, I may set them up in this way. I may set them up like this. So 10 miles per hour. 1609.344 meters per mile. Trying to get my abbreviations right because I use the abbreviations. And so the miles cancel. I don't want that hour, so I can do 1 hour is 60 minutes. The hours have canceled. And then 1 minute is 60 seconds. And that would set me up exactly the same way as what I did before. I would then get this answer the same way that I did before. And what I've done here is shown you what I like to call the train track method. Okay, I use this because it helps me. So anything that has this line in between it, we're going to multiply. So 10 times 1609.34. When I get over here, because I have this number on the top, I'm going to divide by the number down here, okay, because that's why it's on the bottom. So it's a division. Okay, so that's what we're talking about. Now, if you can't do that and you're not comfortable doing that, I don't care what it looks like on your test. I really don't. As long as it has units, that's all I care about. If you want to do it step by step, one step at a time, that works too. I don't care. Again, numbers with units, and it makes sense. Okay, that's what I'm looking for. Another example that we can go through. If I start in miles per hour, we talked about this before, miles per hour, and I want to get to feet per second, right? I'm going 50 miles per hour, and I know this is written up there, but this is how I would think my way through this. 50 miles in 1 hour. I don't always write the one, sometimes I do, sometimes I don't. And I know that I want to get to feet, so I'm looking, okay, I have miles for 520 feet, or I have 528, 5280 feet per mile. I want to get rid of the miles, so I'm going to use the 5280. Miles then cancel. So I'm using it in this fashion, not this fashion, because I want the units to cancel. Okay. So now I'm left with the 5280 feet. Okay, and I want feet. Feet is in my answer, so I'm going to leave that be. But I know that I need to deal with some other things. So I now have this hour down here that I don't want. I know that there's 60 minutes in an hour, or an hour is 60 minutes. I have hours on the top, and that's not what I want. So, or hours on the bottom, and I need to get rid of the hours. So my conversion factor needs to have hours on the top. That's where I was trying to go. So 1 hour on the top so that the hour will cancel with the hour that's already there. And that's 60 minutes on the bottom. Okay. And then I know that there are 60 seconds in 1 minute. Okay? I know that's true, but I can also flip that over. And I know that 1 minute is 60 seconds. Now, did I write all of that out? No. Did I write this in both ways? No, because all I wanted you to see was that I flipped it over. Okay. So I know that that's the case and I can set that up that way. Now I can get rid of the minute that's there. My answer, feet per second, which is what I was looking for, feet per second. And as long as the math is right, as long as I've multiplied 50 times 5280 divided by 60 divided by 60, then my math should work. Okay, so that's how we do that. Hopefully there are no questions about that, but that's my dimensional analysis example for what we're talking about here. Sorry, I was checking that I was recording. I freaked out for a second. Now, the last thing that you'll see right here is that there's a bunch of units that are present. And there are some of the conversion factors that are here. The reason that I put this at the end of this slide set is because what we need to look at next is the in-class practice that was given for this section. So there's dimensional analysis practice that was given for this. That dimensional analysis practice will use some or all of these units at some point. So we need to make sure that we have this available when we work on that set of problems. I'm going to stop here, get ready, get set up for doing that set of problems, and I'll be back with you in a few minutes. Thanks, guys.